if A stands for this matrix, and X stands for this column vector, and I put an arrow over the X to indicate that it represents a vector in this case. And then on the other side of the equal, I have another column vector, which I call B. Okay, then we have here a matrix equation, the form AX equals B. Okay, now as an example, we could have the excuse me, the matrix equation AX equals 700, 300. If this is in the context of the sane and demented question, then the 700, 300 is our population vector indicating we have 700 sane and 300 demented. But of course, what's on the other side of this equal sign, if A is your, we call this a transition matrix, if A is your transition matrix, then AX equals this would have a solution that would consist of the column vector here that would give us this. So it's like, X is now unknown. We don't know what the X is. A might be the same matrix that we had, so let's assume we know the matrix. Let's assume we know the column vector we want to get, which would be the population that we're aiming for maybe in the next year. And let X be the unknown. How would we solve this equation? Well, I say we solve this equation by writing it this way. Okay, but let me relate that to something you should understand just about equations with numbers. Okay, so let's say instead of a matrix equation we had the equation 5x equals 3. How do you solve that? Well, you would say, well, we divide both sides by 5. Okay, and I would say, great, but that doesn't correlate with understanding this matrix equation. So what I want to do is I want to write this, and I crossed this out not because it's wrong, but because I wanted to write it in more detail. So let me restore that. This says x equals 5 to the negative 1 times 3. And it's the same as this. And it's obviously a solution to this, but how do you interpret 5 to the negative 1? You might have trouble interpreting 5 to the negative 1 because it doesn't seem that anybody comes out of our educational system knowing what a negative 1 exponent might mean. But people did say that, okay, well, it would be the reciprocal. Well, that's right. X would be the reciprocal of 5 multiplied by 3. What's the reciprocal have to do with the negative 1 exponent? Then somebody else said very appropriately, well, it's the multiplicative inverse of 5. That was a great statement. Okay? And I abandoned the whole idea of lecturing on the laws of exponents because that was such a good statement. I went a different direction. I said, okay, good, it's the multiplicative inverse. Okay? I did mention, like 5 to the negative 2, what's that mean? It means 1 over 5 squared. A to the negative b is 1 over a to the b. That's a definition by laws of exponents, and you should know that. Not sure how people survive this long without knowing that, but many people do. And there are many people who do understand it too. If you do, it's kind of a feather in your cap because you understand something not everybody does. Okay, well, anyhow, x is 5 to the negative 1 times 3. Now, I really didn't want to stop there. I really wanted to get there in a couple of steps, which is why I crossed it out the first time, and I just crossed it out again. How do we get there from here? By formal steps that don't involve division. Well, our formal step is we multiply both sides by 5 to the negative 1 by the multiplicative inverse of 5. 5 to the negative 1 times 5. Since this is multiplicative inverse, we know that the multiplicative inverse times the number itself gives us the identity, which is 1. So we get 1 here, so we don't have to write anything. We just know that's x. On the other side, we get 5 to the negative 1 times 3. And now we can say, okay, 5 to the negative 1 is 1/5. We multiply that by 3, we get 3/5, and that's our solution. Now that seems like a lot of effort to go to solve this simple equation, but we have to understand formally what that means. And one of the objections I have to our educational system is it doesn't require people to understand things at the formal level. learn how to circle the right number in the SOL, and you're done. Okay. And it does kind of test some of these properties, but not in a way that really leads to people remembering them and understanding them when they see them in a different context. Anyhow, hopefully you understand this. So now you understand, well, if I multiplied both sides of this equation by a to the negative 1 by the multiplicative inverse of the matrix A, I would get x equals A inverse times this column vector. And that would be my solution. All I got to do is know what A inverse is. Well, A inverse is not as simple as you might hope. You might think you just take the reciprocals of all these numbers. Forget that. It's much more complicated than that, but it's not all that bad. That would be really simple. It's just a little more than that. The way you get A inverse. I'm really giving you a preview of something that we'll spend a week developing. But to get the inverse matrix, we simply write down our matrix A, which I'll write down as our transition matrix. And then we kind of augment this by writing down the identity matrix. Now, we haven't talked about this, and it really, prerequisites for this course assume that you know all this, everything that I'm telling you right now. Well, maybe not the sane dimensioned model, but these properties. Okay, these are properties that should be covered in pre-calculus, but very often are not. So a lot of people get here without knowing it. So, I'll do some supplementary videos and refer you to others. Okay, the identity matrix, if you multiply this matrix by any other matrix that's compatible for multiplication, you get that matrix. It's the identity. You multiply it by something, it doesn't change that something. The result is the same as what you started with. Okay? And you'll verify rather quickly that that is the case for this matrix. And it's really easy to remember. Just ones on the diagonal goes to the lower right, zeros in the other diagonal. Okay, now to get the inverse matrix, you know what to do. Once you set this up, you know how to do this. And all you do is you row reduce this matrix until you get this one. And of course you know that when you row reduce the matrix, this is what you want to get. So by reducing these rows so that the matrix on the left becomes the identity, the matrix on the right will become the inverse. It's that simple. Now, of course, that can be a tedious process. You got a lot of steps and you can make a lot of mistakes, but it is a simple process once you learn it. So just learning, knowing, as I think people do, how to row reduce a matrix allows us to calculate the inverse in a simple but maybe tedious way. Okay? And once you have calculated the inverse, you just multiply it by the 700, 300 using the same rule as we used up here. Column, row times column, first times first, second times second, row times column, first times first, second times second, but using the numbers that you get for the inverse. You multiply it by 700, 300, and you get the number of sane and demented that you would want to start with if that's what you wanted to end with. Very neat.